So where should we start? Now that we decided tic-tac-toe is the class we want to start with, it's time for us to start writing some test cases. So let's get to that. So here's what we're going to do. We're going to start writing some code. Use any tool you're comfortable with. I'm a big fan of using IntelliJ. For C#, I often use Visual Studio. For writing Ruby code and other code, I normally use TextMate. Whatever tool you're happy with, use the tool. The strength is not in the tool. The strength is in the way you are going to approach and write this project. So I'm going to start with the project I'm going to create right here. And the project I'm going to create is going to be called tic-tac-toe. Let's say tic-tac-toe app. Let's call it that, tic-tac-toe app. And what are we going to do within the tic-tac-toe app? That's the next thing. Well, we need a package we need to create. Now, if you're programming in C#, start by creating a blank solution, and then within the blank solution to create two class libraries, one for the code and one for the test. If you're programming in Java, typically I would create two different directories with the same package names where we can put stuff. So right here, I'm going to go ahead and click on this right here, and I'm going to say, create me a new directory, and the directory is going to be called the test directory. Now this is a bit tool dependent, but I need to configure this right here. So I'm going to go to the modules and I'm going to ask it to treat this test directory as the test source. And once I do that, I'm going to click on apply and close. Okay, that's all I did. Now I'm interested in creating a package right here, and let's call this package as the game package. Whatever package name that makes sense, go ahead and provide that name. And typically in Java, namespaces or packages are all lowercase with dot separation, and usually each dot separation becomes a directory in itself. So feel free to create packages. But start by creating packages or namespaces first, and likewise here, I'm going to go ahead and say new up here to create a new package. And this is going to be another package we're going to create, again, game. Notice that the package name is same across the source and the test. In the case of C#, I would keep two different assemblies, the test library and the code library, whereas in the case of Java, I normally put them in two different directories, as you can see here. Well, that's great. Now we got to start with the class, a test class we want to create. So here's my test class. I'm going to call it as tic-tac-toe, and I'm going to call it as test. That's the name I'm going to provide for it. And that becomes the test class, as you can see right here. Now, in order to start using this, we need to start writing test cases. Well, the very first thing we need to do is to make sure that the libraries are set up properly on the machine, the tools are installed, and everything is going to work. Now, if you dump 20 lines of code and things don't work, and you ask for help, that person who comes to help, the first thing they're going to ask you is, what you doing? If you show about 20 lines of code, they're going to look at it and say, what does all this code do? Oh, you shouldn't be calling that. Oh, you don't have the environment set up properly here. Oh, you should really pass that. No need for all of that. So start with something called a canary test, where a canary test is the stupidest test you could ever write. It is going to say assert true is true. That's right. And you may say, that's stupid. Well, that's the whole point. It doesn't take a whole lot of effort to write it, and that helps us to make sure the environment is set up properly and we can get it out of the way. On a particular project I was working on, I was being the agile test-driven development coach for them, and they wanted to embark on test-driven development. So when I sat down with the developer said, oh, I got everything set up on my machine. Well, if that's the case, why don't we write a canary test? And the developer said, what is a canary test? Well, you do an assert true is true. Well, that's stupid. Why would you write something like that, he asked. Well, yeah, that's stupid, right? So let's get it out of the way. Well, it turned out it took us 40 minutes to get the canary test to run because the environment was not set up properly, and we ran into so many different errors, and we had to bring in a few people to help us through. So the point really is you want to get through these canary tests as the first step. You don't write canary tests for every single test you write. I want to emphasize it. Don't write canary tests for every single test you write, but instead you do this when you start a new test project. I had a client email me and ask, why are my developers writing canary tests in every single test class? Oh dear, that's not the intention. This is just to get the tools set up. So start with a canary test. So what are we going to do within this canary test? Well, let's go ahead and first of all write this canary test. So I'm going to create over here a test called canary. and I'm going to say assert true is true. Well, that is the very first thing we are doing. Now, of course, this requires test. Where is the test coming from? Notice that's nowhere to be found. So I'm going to go over here to the dependencies, and I'm going to add the dependency over here to the jar files. So I'm going to ask for opt over here and JUnit, which is where JUnit is located on my machine. So I bring over JUnit. And likewise, that also requires one more assembly, or rather jar here. And I'm going to say over here, as for opt and hamcrest over here, and that brings up hamcrest. I'm going to go ahead and reference that as well. And those are the two things I need here for Java. And I'm going to click on apply and click on OK to get that out of the way. So as soon as I do it, notice that the tool says, hey, do you want to use arg.junit? Oh yeah, absolutely, go for it. And likewise, I'm going to select assert test and ask for static import on the assert, and that brings in as well. Now that we have brought in those two, let's go ahead and run this, and you can see that the IDE is running this, and you can hear the canary sing. We got a green bar. Well, the word canary test comes from the saying canary in a coal mine. The miners take a little bird canary, and canary has the nature of, being active and singing, but it also is very sensitive to certain types of fumes. So this is very good for the miners, not so much for the canary, after all, poor thing. So if the canary smells a bad fume, it dies, and this is an early warning sign for miners to get out. So that's a sacrificial test, and that's all we did. So we wrote a little canary test to make sure the tool is set up properly and everything is working. Like I said, you write only one canary test per project. When you get started, you don't keep writing this over and over. Now, you come to work on a Wednesday morning and you assert true ends up failing, you're going to have a very long day. So the point is, this is a very sacrificial test just to make sure that the tool is set up properly and things are moving forward. We're going to talk about certain principles, practices, and tasks along the way, but typically, I keep the tasks in a little paper, literally on a little paper. So I'm putting it here on the computer because you can't really see the paper I have over here. So it's easier for you to see what's on the computer. I strongly recommend that you don't keep the task list here on the computer, but you keep it on a piece of paper. Now, of course, if you want to share this with a pair you're working with, go ahead and feel free to check it in. But generally speaking, we normally keep it on a little piece of paper. So identify the tasks that you want to think about. And here are some of the practices and principles we're going to follow along the way. The very first practice is jot down tests that come to your mind. That's the very first thing to think about. Just jot down the things that come to your mind. At this point, don't argue with yourself or a colleague you're pairing with about whether a test is a good test or not. Simply just write it down as you can think about. For example, for a tic-tac-toe game, what are the tasks I would want to start writing? Remember, the goal is the test should lead you towards implementing code and evolving code. So I can think of one test, let's say game not won by anyone when the game starts. So that is my very first test. Game not won by anyone when the game starts. So when we create a new game, there are no winners. So that is my very first test I could think of. Now, as you think about tests, just jot that test down. And then once you have a few tests, pick the test that is fairly easy. So easy and quick to, let's say, to write. So you don't want to spend a lot of time with a particular test. You must be able to build your code, grow your code using a series of tests. So come up with a few tests and keep moving forward. And then as you are writing these tests and writing code, if a particular test will take maybe 10 minutes to implement, but maybe by picking other tests, each of which may take 2 minutes, you probably have built up enough code to make that 10-minute test be implemented maybe within a minute moving forward. So try to pick up the test that is easy and quick to write. But just because it's easy and quick, don't focus on it. Pick a test that is is valuable, right? So it's got to be somewhat valuable also when you're writing. So pick a test that is valuable to write as well. Well, at this point, I can't think of many other tests. Well, game not won by anyone when the game starts. Maybe we could just start with that test to begin with. So let's start with that test. What are we going to do? Well, let's go ahead and write a test over here. And the test I'm going to write is game won by none at start. So that is my very first test. Now, how am I going to validate this test? What am I going to write to validate this test? Well, first of all, I need a tic-tac-toe game. So I'm going to say tic-tac-toe, and we will simply say tic-tac-toe. And once I create a tic-tac-toe, equals, let's go ahead and say over here, equals. And what am I going to say? New tic-tac-toe, that's the object we are creating. And then I'm going to ask for the fact that nobody has won the game. So we could say tic-tac-toe dot, let's go ahead and say game winner. And who do you want the winner to be at this point? Well, we want nobody to have won the game. So what should we really return from this? Well, I'm not sure what to return at this point. We could think about it, but I'm sure it'll fall into place very quickly as we move forward. So why don't we simply say, just for now, simply say assert equals, and then let's say none to say that nobody has actually won the game at this point. So we'll say assert equals none won the game, and we don't have any particular person who has won the game. We can make the decisions a little later on, so don't be too fearful of that at this moment. Well, that requires us to implement a few things. Let's implement the class called tic-tac-toe, and we want it in the game a package in the source directory. That's where it placed it. Now let's get back to the assert equals. Let's make it happy by providing the static import for that. And then the next thing here is the winner, and let's go ahead and implement the winner. So that's returning a string right now. That's okay. Let's keep it that way. But what should we return from within this particular method? Well, one of the tenets of test-driven development is a practice to follow is write a failing test first, then write minimum code to make that pass. So, pardon me, you're going to write a minimum code to make a failing test to pass. Well, in this particular example, our test is already failing because there was no code. So you could consider that as a failure case. I want you to take this with a grain of salt. I've had programmers come and get angry at me because when I wrote that test and I wrote the code, it just passed, and they were apprehensive because you're supposed to make the test to fail first. For example, in this case, if I run the test right now, notice the test is failing because we were expecting a none, but the code was returning null. But that's a little bit silly in my opinion because yes, the code is going to fail, but it already failed because the code did not exist. But pay more attention to the second part, which is then write minimum code to make that test to pass. So the goal is to make the test to pass with minimum code. And in this case, the minimum code really literally is returning none. Now, clearly, you're not going to leave this code forever. And if it is all the code you need, you could get rid of the test and the code because it doesn't serve any purpose. But the point is you would be replacing this code with real code eventually. So don't worry about this right now. The goal here is to grow the interface first and then come and fill in the details after that. So this is a good enough test to begin with for this particular case. So that is our very first test, and that test is passing. As you can see here, when we run this code, that test is passing because we are returning a none, and that's what this test is expecting. So all we did at this point was just to make that one test to pass. So we're going to be developing these tests and moving forward. Well, great, we have one test passing. What's the next thing we should do? Well, this is the tic-tac-toe game. So a person could come and place a peg, but there's also somebody who has to decide who the first player is and who the second player is. So how do we decide who the first player is and who the second player is? Well, if I'm playing the game with you, you and I could decide, do you want to go first? Do I want to go first? So we could pick and choose who wants to go first. So that could be a discussion we could have. So we could say, pick the first player, right? So that could be the first thing. We could also then say, pick the second player, but that may actually fall in place. But don't worry about it. Just write it down. Okay, now we have a first player we have selected. And what should we do now? Well, the first player now has to place a peg. So we could say another test is place peg and at some location. Now immediately some thought should come to our mind. Where does the player place the peg? So again, a few practices to think about. Write or jot down a positive, negative, and exception tests. So for each of the tests that you are writing, think about positive, negative, and exception tests. So place a peg at some location. Well, place second peg, or you could say the second player places the peg, right? So we could replace this, for example, saying first player places peg at some location. And then we could simply say second player places peg at some location. But that brings up some negative tests. Place peg at an occupied position. And we could also say in this case, place peg out of row range, and place peg, we could say place peg out of column range as well, right? So those are some of the things to think about as negative tests. Well, what if we place a peg where another peg exists? What if we place a peg out of row range, out of column range? Well, those are some of the tests we can think of. Now, we got a by-left test. Don't spend too much time thinking about tests. Sometimes we think of tests as we are writing code, and that's pretty natural. Our mind is multi-threaded. While we're writing code, other things come to mind, some of them not related to work. But when another thought comes to your mind, don't jump on to write the code for it, but instead switch over to your task list and jot down the next test that you would want to write, but focus then back on the test you are writing. And the reason is, when you're writing a test, you want to keep the focus on the test, and any other thought that comes to your mind deserves its own time and focus. That's why you put it on the list and you come back and look at it later on. That way you don't get distracted while you're writing the code and the test. And at the same time, you're not forgetting that other little idea that came to your mind, you're jotting it down. Likewise, when you're writing a test, if you want to refactor, put a note here to say you want to refactor and come back and refactor later as well. Well, okay, so we got a bunch of tests. Which test should we pick next? Well, remember the rule we talked about. Pick a test that is fairly easy and quick to write, but also one that is valuable. Well, clearly, these tests are valuable for error checking purposes, but we cannot really check for them until we actually have placed a peg. So it's important for us to place a peg. But we also have to decide which player goes first as well. So how do we really deal with that? So we pick the first player. So let's entertain that thought for a minute. How do we pick the first player? Well, to pick the first player, we're going to go to the tic-tac-toe board and say, so let's go ahead and say pick first player, right? So to pick the first player, what should we really do? Well, we could first create a tic-tac-toe board that we want to create. So let's bring that in here. And now that we have the board, we could say tic-tac-toe board dot, and we could say, set first player, for example. Now, when we say first player, what are the things we actually need to set the first player? Well, we certainly would need a player object to set. Well, the good news is our strategic design did have a player class in place, so we could do something along those lines. We could say new player, and of course, we want to know who the player's name is. We could say Venkat is the first player. And then, of course, we got to say what the peg of the player is. So we could say new X peg. After all, our domain model has an X, and Venkat decides to use X as the peg. So we could write this. And then once we write this, we could say assert equals. And then, of course, we want to make sure the player is the player we expected. So we could say Venkat, comma, and then we could say tic-tac-toe board dot. We could say, for example, get first player. And once we get the first player, let me fix that, get first player. And then we could say, once we get the first player, we could ask for the name of the player. We could say get name. And likewise, we probably would have to make sure that the peg we have is an X peg. So we could say get player dot get peg dot, we could say get whatever the phase of the peg is. We could find all of that. Well, if you look at this test, This is trying to set the first player and get us all these details. Well, we could just go implement all this code, but let's stop for a second and think about it. How does it feel? Do we want to set a first player? That appears more like a getter and setter. It appears like we are injecting a state rather than focusing on a behavior, so it leaves a little bad taste after all. We are creating a player class. Wait a minute. Are we going to test the player separately? Are we going to really work with the player now, or should we keep the focus on the tic-tac-toe board? But then this also seems like a lot of work. We got to create one method, one class and a constructor, and another class, right there, one method and another method. Oh boy, that looks like we got to create 5 things for this test to work. Seems really heavyweight, isn't it? So that's another practice we need to get comfortable with, and that is listen to the whispers of your tests. So your tests are whispering, and listen to those whispers of the test as you are working with the code. The tests are trying to tell you how they feel, and you should feel similarly. Boy, this looks like it's pretty heavyweight. But let's ask the question, why are we setting the first player? Well, after all, we need to know who is going to play first, isn't it? Okay, let's say that's correct. Then why are we creating a player class? Well, of course, we need a player class. The domain model said we need a player, isn't it? Yes, but why are we giving the name for the player? Well, we need to know the name of the player, obviously, because when the player wins, we need to report who the winner is. But wait a minute. Is the player actually winning right now? We haven't even started the game. The win is only when they have placed enough pegs. So why are we worried about who the player is at this time when we need it for the winning purpose? Well, that brings up to a principle to think about. It's called the Yagni principle. The Yagni principle stands for you aren't gonna need it. And usually put a word yet after this. You aren't going to need it yet. So you are not going to need it simply says the classes you think about, you really don't need it. At least you don't need it yet. We need the player to decide the score and store the score, but I don't need it yet. So I want to postpone things until the last responsible moment. So last responsible moment, what does that mean? It is a moment beyond which you cannot postpone a decision. I can postpone creating a player further down until I need it for score. I don't need to bring it in right now. So we can postpone the player quite a bit moving forward. So as a result, we don't need the player at all, at least not yet. So let's go ahead and rewrite this with that expectation. So how about doing this? We can say tic-tac-toe dot set first player peg and then new x, and then we could say assert equals, and then we could say x over here, and then we could say tic-tac-toe, for example, and dot get first player. We'll say simply first player peg, and then get phase of the peg, obviously. Well, okay, that's a notch better. We got rid of the player. After all, we really care about whether to place an X or an O first, and we don't really care about whether it is Venkat or Joe or Sarah that's going to play the game. That name information is needed only later. As far as the game is concerned, placing X and O is more important. We don't care about who it is. It's quite possible that Joe is sitting on a corner and letting his kid play, so it doesn't matter who the real person is, and that identity of the player, that's correct, the identity of the player is not important at this moment. That is unnecessary distraction, unnecessary complexity. That is how systems become complex. So if you really think about it, the tic-tac-toe game doesn't care about who the player is at this level of the game. It may care about it in the overall game, but not at this layer. So if you remove the detail, the design becomes a lot simpler. And that is something to keep in mind, is as a practice, strive for simplicity and reduce and remove. So strive for simplicity, reduce and remove accidental complexity. So accidental complexity are complexities we introduce into solution space. We should try our best to remove these kinds of accidental complexities in the game. Well, that's great. We got rid of the player at this point. But what about this? Well, if we're going to place an X, this requires us to create an X peg. And then, of course, we have to come back and make sure we create this. This requires us to create one method, one class, and one function at least for this to work. Well, that also probably is going to lead to creating a peg base class as well, as we can see up here. However, if you really think about this a little bit further, we are dealing with pegs after all, but why do I care to have a peg class? Why can't I simply say tic-tac-toe, for example, dot set first player, so let's say peg, and how about simply saying X? Well, then we can simply say assert equals in here, and the assert equals is going to check for X, and we can say tic-tac-toe dot get first player peg, and there is no more face to call after that. Well, this clearly is a lot simpler. Maybe we need a peg, but maybe we don't, but it's not very clear. Why not postpone it? And if we really need a peg, we can bring it. Seems like a good idea. We can postpone that and simply send a X, but that brings up another question. If you can set a X, it's possible you set a O as well. But if you set a X or a O, what if somebody sets a W? You got to write a test to make sure that nobody sets a wrong peg. So quickly jump over to the test and make sure that the peg set first peg, that's what we want to really focus on. So set first peg should not be other than X and O, right? So that is something we need to keep in mind as something we need to handle. We don't have to write code for it right now. That goes into the task list right away. So this is definitely a lot better than what we started out with. Let's think about it. Can this be simpler than this? Well, rather than sending X, if X is going to start, we could say set first player peg is X. So we could maybe say that and say true. And if it is not X, it becomes O. Oh, wait a minute. If we do that, then we don't have to worry about setting W, isn't it? Then, of course, we can simply say X. This should still be working properly, but this will eliminate the problem of setting something other than an X or an O. Well, maybe a notch better, but that requires using the is X over here. But if you really think about this a little bit more, what does the game really want at this point? Well, we want to think of an action to perform. So I think we are barking at the wrong tree. If you go back to the task list, the game was won or not. Nobody won the game. Well, we're trying to set the first player, but why don't we think of something a little different? Why don't we perform an action? What's the very first action somebody wants to do with this particular board, tic-tac-toe board? To place a peg. What if we place a peg? If that's what the action we want to perform, what peg are we going to place at first? We're going to place a peg, whatever is the first player's peg. We seem to go in a little circle here, but if you really think about it, whether it's an X or a O, a W or a L, a donkey and a monkey, or a goat and a tiger, it doesn't really matter. You could have multiple UIs for this game. One version of the game may have an X and an O. Another version of a game may have a circle and a star. Yet another version may have a goat and a tiger. These are all pure visual representations. But what's really fundamental to the game is that players take turn. The first player goes first and the second player goes next, and the first player goes again and the second player goes after. That is what we really care about. Well, if that is all we care about, then we don't need this at all, because we can be placing the first peg when we make the first move. So all that simply goes away. We don't have to do that at all. Wow, look at the fact that that code just went away and we did not even write a single line of code in here. Now, what is that process we just went through where we decided here's a method to write, here are the parameters to pass, here's the class to write, and then saying, we don't need any of that. That's of course design. That's a very tactical design. But what our tactical design did at this point is it said to us things like player and peg are things we don't quite need yet. Yagni, you aren't going to need it yet. So we can make this a lot simpler than what our strategic design is pointing to. We could probably make this a lot more simpler. So what should we do to make this simpler? Well, these tests go away and we can get to the point where first player places peg at some location. That's the most interesting part. So let's do that. So the test we're going to write here is, we're going to say first player, so place, let's say first peg. How about that? So we are asking it to place the first peg. Well, where do we place the first peg? We need a tic-tac-toe, obviously, to do this. So let's bring in the tic-tac-toe over here. And then we're going to say tic-tac-toe dot place peg. And where do we place the peg? We could say new cell, and we can tell what cell to place this peg on. Where in the world did that cell come from? Well, sure, our cell is part of the domain. It is part of the strategic design we created. But thinking about it again, we could say, why do I really care about a cell? After all, it's a grid. So why don't we simply say a particular row and column? So maybe I want to place it at 0, 1. That is where I want to place the peg, row 0 and column 1. That's fairly simple, but what do we want to do when we place a peg at that location? Well, every test has to have an assert. So let's go ahead and write that down as a practice. So every test should have an assert. Let me add while we are here, do not write more than one independent assert per test. So what does that really mean? When you're writing these tests, don't put multiple asserts in one test, multiple independent asserts. Sometimes you may say, well, I want to do this action. I want to make sure the first name is this and last name is this. Maybe that's one atomic operation of setting the first name and last name, so those two asserts are okay. But don't try to perform 2 or 3 independent tests in the same test and do different asserts. Keep the asserts as minimum as you can when you write these. But every test should have an assert. So what is the assert I'm going to have here? So assert equals, now what do you really want when you place a peg? Well, you know what you want. You want that peg you place to be the first player's peg. We don't know what the first player's peg is, but we know there is a first player's peg. Whether it's an X or a donkey or a monkey or a flower, or it doesn't matter, it's a first player's peg. So why don't we simply say peg dot first? So we have a peg which is called first. That's what we are calling, and we are telling that our assertions should say that we should get back, when we place a peg, we should get the first peg back. Well, what in the world is this peg after all? Well, we could model the peg very easily within the class itself. So let's go to the place peg, write a method. Here is the row, here is the column, and what is the minimum code our test is expecting? Well, it is expecting to get a peg back, and we want to simply say peg dot first. That's what we want to return. So we can easily create over here within the class that we are working with, we can simply say enum, we could say public enum, peg, and we could say none, and we could say first, for example. So we have 2 pegs on our hand, the first peg and the none peg, obviously, because we don't want any peg. That's possibility as well. But let's not jump ahead. Let's just say first for a minute. See how the tendency is to jump ahead, write the minimum code needed. Well, what in the world is this peg? Well, the IDE already prompts us peg is just an enum within that class, and that's what we brought, and this is going to be the first that we have within that. Either we can use it like this, or we can perform an import, if you will. So we could simply say, why don't you bring me an import? So we can go up here and say something like import, let's say in this case, game dot tic-tac-toe dot peg, and we can bring the reference to it. Then we can simply refer to peg here directly. So let's go ahead and run this test and see what the test is telling us. That was very minimum code, and we simply said when you place a first peg, what you ended up placing is the first peg. So let's go to the task list now, and we just implemented this test. It's time for us to place the second peg at this time. So let's go back here and write a test, but wait a minute. If I start writing another test right now, calling place, let's say second peg, well, notice in this case, we need to copy and paste this one more time, and that's going to result in duplication of code. So we need to be sensitive to this. Another principle to think about. So keep it dry, and the dry stands for don't repeat yourself. Now, this is not just in the test code, but also in real code. We want to avoid duplication of code and duplication of effort. So keep it dry. So we don't want to be duplicating this over and over. So what do? Well, here's an idea. We can take this from here and we can take this from here and simply move it into the class as a member right here. Well, that's great. Now the code is dry. We're not duplicating that everywhere, but this has other problems. If one of the tests pollutes or populates this object and then sends it over to another test, it's possible that the test worked for a while, but when we change the order of the test, introduce a new test or run some test partially, we probably would not really get the right result because of this dependency we introduced. So another practice to think about is something very important to follow, and that is keep tests isolated from each other. So while at this, let me just simply throw this at you. Tests have to be fair. Now, what does that mean? They have to be fast. If they're not fast running, you won't run them after all. Tests have to be automated. So we should be able to run them automated using tools, automated scripts, what have you, very easily. They have to be isolated. This is what the point we just talked about. They should be isolated and independent of one another. So you could say independent instead of isolated. And then finally, R stands for repeatable. You want to be able to repeat this test over and over and over and any number of times. So you want those to be repeatable, and having these tests dependent on each other will not make it very repeatable in different order. Okay, that means we're going to move this back. Now we have the dry principle violation. So it looks like we are stuck between a rock and a hard place. What do? Well, there's a way to fix that problem, and we can create what is called a setup method. So we can say before, and in this case, we will create a public void, let's say setup, and within the setup method, we can go ahead and say tic-tac-toe equals new tic-tac-toe. Now, what is the benefit? What's the difference? Well, the difference is, let's go ahead and put an output here, set up for a minute. We don't need this quite a bit, but let's go ahead and write a method here, which is going to be a method that's going to help us to tear down and say we don't need this anymore, and we can say we are done with this execution. We could write a tear down method, for example. So we could say I'm done executing this. Let's see where the tear down comes from. So let's say if there's a setup after, and there's the after right there, that's a tear down method, and I'm going to say void, let's say after or in the end. So let's say in the end. And what does this do? I'm going to simply output here done, for example. If I run this test, notice the output, we have setup done, setup done, setup done called so many times. So what's literally happening is every single one of these tests are being sandwiched between a call to before and a call to after. So before test, after, before another test, after, before yet another test, after. So every test is sandwiched between a call to this setup and tear down. So as a result, this particular call to create this object is done before every single test. This is like in a restaurant, people go eat in a nice table. When they leave, that table gets cleared out, a new table is being set up with all the utensils and everything, silverware you need for the next set of people to come and sit down. That's exactly what the setup is doing. We often don't need a tear down, but it's available if you need to use it. So we have set that up right here in the setup. Now that the setup is setting up the tic-tac-toe object, we can readily use that in these tests. So that brings us to this. So let's make sure the tests are passing because we did a little refactoring before we go any further. So now place the second peg. So we're going to say tic-tac-toe dot place peg. Let's say at 0, 2 for a minute. And now we're going to say assert equals. And let's say peg dot second over here. And this is going to be tic-tac-toe dot place peg at 0, 1. Well, 0, 1 is the same location as here, but this time we expect a second to be provided for us. Let's go ahead and implement the second in the enum. And you notice that second came about here. You could move that around as the first and the second peg like that. And now that we have these two pegs, what do we want to do? Well, let's go ahead and run the test and see what it does. And you can see the test is failing because we are expecting a second to be returned, but what it returned was a first. Of course, no surprise there because we hard-coded to return a first. So we have to really implement a little bit of a logic to make this work. So let's try what we can do here to implement this logic. Well, let's go ahead and say that we want to know what peg to use first. And in the very beginning, we're going to use a first peg. Once we place a first peg, the next peg we want to place is the second peg. So we could create a little variable here, and the variable could be called as current peg, but we also need to know where to put these pegs and store them. So we got to make a little bit of a decision as to what to store and what to return. But for now, we could simply keep a little current peg and keep going for now. So let's create a current peg. So current peg equals, and what do we want the current peg to be? Well, in the beginning, whatever that the current peg is going to be, it is going to be that one, right? So we will say here something like peg temp equals, we'll say current peg, and then we'll say current peg is going to be equal to, well, we got to change the current peg. So if current peg is equal to, let's say peg dot first, then you want this to be the first peg. We could use a little, what do you call that? The ternary operator here. So this would be peg dot second. Otherwise, it'll be peg dot first. So we could set the current peg to whatever that value is based on its current value. Then, of course, we can simply return from here the temp, or we could say this is the previous peg we are returning. Let's entertain this thought for just a minute. This requires us to create a field called the current peg. So we'll create a private peg current peg, but we got to initialize that peg somewhere also to begin with. So let's go ahead and implement a constructor for that here. So in the constructor, we're going to say current peg is equal to peg dot first, and that's what we implemented. So let's go through the logic here. You come into the place peg, you store away what the current peg is. First time, it's going to be the first peg, and then you toggle the current peg and return whatever it was before. Second time around, this is going to be the second peg, and you're going to return the second peg, and of course you would have toggled it further down. So let's go ahead and run this code and see what this code is doing, and you can see the test is passing, so that met this expectation right here. But let's get back to the code for a minute. So when tests pass, there is something else we need to do. This is yet another practice. So when tests pass, take a look at the code to see if it can be simpler, can be refactored. So you want to be able to refactor the code and make it simpler and better. Well, if you look at this code, I would argue this code begins to look a little smelly. Because if somebody comes to this code and looks at place peg, what are they going to say? They're going to look at this and say, what's going on here? You're storing this temp, and what is that logic over there? That takes away some time attention from you to see what's going on. And when you're done with understanding this, what do you normally do? You say, oh, darn it, I know, we're just toggling the peg. So what's your first temptation? Toggle peg. Well, I strongly recommend you don't do that. Any opportunity you get to write a comment is an opportunity to refactor that code into a self-standing method so it becomes easy to communicate. So notice what I'm going to do here. There is two problems in this code. We are saying we want to set the current peg, but also notice this is telling us what's the next peg to use given a current peg. So we can easily take this one and extract method from it. So I just applied the extract method refactoring, and I'm going to say toggle peg, and notice that that simply became a method called toggle peg. Now if you look at this code, it simply says in place peg, store away that current peg, toggle the peg, and return what you had before. Well, that's a lot more easier to read than the code we had a minute ago, and that gets moved to a separate method. If you really want to, you could write some test on toggle peg. If the logic is trivial like this, I probably won't be tempted. It gets tested through here, but other times you would write a test for this. Of course, you cannot write a test easily on a private method, but normally I make it a package protected, meaning I don't put any public or private. Then I can access it from the test class very easily, and so we could do that as well. So that is something we can do to write a test on it separately. Well, that brings us to the next point. We wrote this little test to write this. We did a little refactoring. The next step, of course, when you do refactoring is to make sure all your tests are still passing, and they seem to be, so we are in good shape. So we finished that particular test, which is to place the second peg. Now, obviously, you could write up code to place a third peg so that you are able to get a third peg from that location. But we also want to know what peg we are placing, but we need to really come back to working with certain other logic. But always introduce a logic only when a test prompts you to do that. So obviously when you look at this code, this is a bit of a cheated logic because it's simply storing into a current peg and returning. We know that we need to really store the pegs so that we can do some work. So how do we go towards that? Well, don't start modifying the code to put and store pegs. Instead, let some other test lead you towards that. What kind of test would be right? We could either think of new test or look at one of the tests we already have. Well, looks like we do have a test that can help us. Place peg at occupied position. Well then, what do we do if we place a peg at an occupied position? This is a design decision we have to make. So think about what you would do if a peg is placed where another peg is already there. I can only think of two possibilities. One, blow up, throw an exception and say, oh, how dare you put a peg where another peg is. So you could throw an exception. Alternately, you could simply ignore and say, I'm not going to place a peg. So visually, there's a peg already there. You try to poke on it. Nothing really changes. You don't see the peg change. That's another solution. Which of those is the right answer? I don't think there's a right answer. That's debatable. We can discuss it and decide exception is better or ignoring it is better. It doesn't matter what decision you make. That decision has to be documented through the test cases. So design decisions have to be documented through test cases, right? So that is the essence. You are documenting the behavior you want in the code. So let's go ahead and try that here. So I'm going to go to the test and I'm going to write the next test. And the test says in here, place peg at occupied position. So now that becomes the documentation for the behavior. You're not arguing what the right answer is. Whatever that is, you documented it here. Tomorrow, if you want to change it, that's perfectly fine, but then that'll affect the test because you're changing the behavior that you expect of this code. So what are we going to do here? Let's pick one. Should we throw an exception or should we just ignore it? Let's ignore it just for picking one option. So what are we going to do here? Well, tic-tac-toe.placePeg, and I'm going to place peg at, let's say, 2, 1, and we know that it's going to be the first peg at this point. And now I'm going to say in this case, I just wanted to ignore, meaning it should give us exactly the same result as it did before. So assert equals, and I'm going to say peg dot first, comma, place peg over here. So place P-L-A-C-E, there we go, a peg, and I'm going to say 2, comma 1. So we are placing a peg one more time, but we are placing it at exactly the same location as we did before. Well, technically this would be second if this was a different location, but because we're ignoring, it is going to be whatever that came out of this, which should be the first. If we run the test this time around, notice that in this case the test is failing. It's expecting first, but it got a second, and clearly that problem appeared where? Well, we can see where that problem happened. If you click on the link over here, and you can see from the link that's on that assert is where that's failing. Now that's obvious where it's failing because we were simply toggling. We did not store really the pegs at any given time. So it's time for us to implement that. So how do we store this? Well, it's after all a grid we talked about. So let's go ahead and say a final, so private final int size equals 3. Why 3 as a size and not hard-coded 3? Because we want to avoid magic number in the code. This is going to be the size of the grid, so we put a size in there. We can also say here the grid we want to create. We could say over here a peg, and this could be purely cells that we are interested in creating. So we could say cells over here equals, and what are these cells going to be at this point? Well, this is going to be new peg, and we're going to say size, and then it's going to be size also. So we create, excuse me, pegs of that particular dimension. So now that we have the pegs on our hand, what do we want to do here? Well, clearly what we want to do here is we want to say cells, and then we're going to say row and column, obviously here, equals, and we're going to specify what the particular cell is going to be. Well, that's going to be the current peg, obviously. And then once we set it, we simply need to return the cell at that row and column. Well, this is going to be the regular behavior. However, excuse me, we're going to say do not place a peg if that position is not empty. Well, to make empty work, we're going to specify none over here, or we could say empty. And in this case, we're going to say do all of this if the cells at row and column is not equal to or is equal to peg.none. Then go ahead and do this operation right here and the toggling, but no matter what, simply return to me the cell at that location. Well, let's see if the code is going to work. Let's go back and run the test this time to see what it is doing. And oh boy, that's failing. What's the problem? Well, it expected a second but got a null. Let's see where that error is coming from. Line number 37. Oh, that's placed the second peg. What could have gone wrong in that? Well, we placed the first peg at that location 0, 2, and then we are calling place second peg. So if you go back to the code and rethink through what just happened, the feedback loop again quickly told us something is failing. So we are saying if at the row and column given, if the peg is none, then set the peg at that location, toggle the current peg, and return the cell at that location. Then when we come back again to the next call, it is going to be the second peg is the current peg, but this should be a none because at that row and column, it should be a none. Well, okay, so I'm definitely missing the point. Let's understand why that's failing. Well, to understand that, it is clearly telling us it's getting a null. Aha. And the reason for that is, well, if you look at this code, we are saying if the cell at row column is none. But when did we tell it that it should be none? We created an array of pegs, but we never initialized it. If you are following along this example and maybe trying to code in C#, you would not have gotten an error at this point. And the reason is when you create an array of enums in C#, C# automatically initializes it to the first element, but Java doesn't. So to fix this, what we have to do is go to the constructor and we have to iterate from this to the size, if you will, and then provide one more iteration here. So this is going to be iteration from the size also. And now we are going to say here that the pegs or cells at I and j is going to be, and we're going to specify peg.none. That's initialization is required in the case of Java, but that's not required in the case of C#. So that is a language related behavior. So when we go back and run this little code, you would notice the test is now passing. So that was an initialization problem. This is another thing I really like, because when I code this in C#, I don't write this constructor code we just wrote, because the test says you're good. Whereas in the case of Java, it tells me I'm not okay. I had to implement it. So we implemented one more test, and the test we implemented is place peg at occupied position. And guess what it did for us? It now grew this code just a little bit. So in other words, as you keep creating tests, you should see the code skin forming and the gut slowly forming around it. And that is usually the way this is going to grow. Well, then we could write a few more tests like place peg out of range, place peg out of column range. I'm not going to write those tests, but we can typically write those tests, and you will see. Well, actually, let's go ahead and do that. Let's write the one test out of range location just to discuss the exception test aspect of things. So I'm going to write here place peg, place peg out of a row range. So how would I implement this? Well, we know that the size is going to be that value of whatever the size is, 3. So what do we do in this case? We can say tic-tac-toe dot place peg, let's say 0, comma, let's say 7, for example. Well, in this particular case, our grid is 3 over 3. If there is a variable number, we could also bring in some constant and use it. But what do you want this to do? We could argue we want this to be an exception test. So I'm going to put a try block here, and I'm going to call a fail over here. And the fail says expected, we'll say expected. So this is a fails call. So let's say fails. And what should we do here? Expected exception for stepping out of bounds. And now, of course, we need to know what kind of exception to expect. This could be an index out of bounds exception. And then, of course, if that comes up, that's actually good. So that is our exception test. Now, some of you may realize there are other ways to do this. For example, you could say expected exception, and you could specify what exception to expect. I prefer not to use that notation because you want to make sure the code that's throwing the exception is actually the code that's throwing the exception and not some other setup method you're calling within this. So as a result, I normally either use this verbose method or I look for lambda expression syntax where it can be a lot simpler in languages that are tools that support such expression. For example, NUnit for C# has a little construct that says throws. So you'll say assert throws and provide an action to it. That's a very nice concise syntax compared to using the annotation or attribute in the case of looking for those tests. Well, let's go ahead and run this test and see what happens. And when we run this test, you can see the test is passing. That's of course because our code was throwing that exception when you step out of the bounds. So that's working as you would expect. So similarly, you would write a test for the column range as well. Well, set first player peg other than XRO, that test goes away because our design doesn't allow that. That brings us to the point, what are we going to do next? And the next step would be to look for a winning of the game and write the UI. And of course, after we do that, we will discuss a little bit about the lessons learned. This is a good time to take a break. In the third part, we will finish up, write a few more tests, drop the UI, and discuss about some pros and cons and call this done. So that's where we're going to stop for now.